Kia ora guys, welcome to the Year 10 Physical World series. This is video 3. So before we get started, I'd like to ask you, what do you think gravity is? Let's watch this video.
So what is gravity? I'll bet most of you think it's what goes up must come down. Is that right? Well, sorta, but not really. Technically, the law of gravity is an equation. It is F equals G times M1 times M2 divided by R squared, where G is the universal gravitational constant, M1 and M2 are the masses of the two objects, and R is the distance between them squared. That was easy, right? Probably not. But what does this actually mean? Well, it means that, everything is attracted to everything else. And what I mean by that is that if you have two objects, any two objects, they are attracted to each other. Okay, let's try and wrap our minds around this. What happens when you drop a rock off a cliff? It falls to the earth, right? Well, yes, but something else happens. You see, the law of gravity says that both objects, the rock and the earth, are attracted to each other. This means that the rock falls towards the earth, and the earth falls towards the rock. Wait a second. You mean to tell me that if the earth falls up to meet the rock? Yes, that's exactly what I'm saying. And the reason you don't see the earth fall up to meet the rock is because the objects move towards each other proportionate to their respective masses. The earth is much more massive than the rock, so it moves a very, very small distance. And the rock is much less massive, so it moves farther with respect to the earth. Maybe a better way to understand gravity is to take two teenagers in spacesuits and place them far out in space, away from all the planets and the stars. It turns out they will be attracted to each other. I'm not talking about that kind of attraction. See, they have mass, and since they have mass, they will move towards each other. They are attracted to each other. Maybe one more thing might help. Have you ever played with two magnets? You know the magnets with the north and the south poles? When you take the magnets and put them closer to each other, they move together. They are attracted to each other. And the closer they are, the stronger the attraction. Think of the mass of the object like the strength of a magnet, and the distance between the objects like the distance between the two magnets. Now understand, I'm not saying that gravity and magnetism are the same. They just behave in a similar way. Let's think of one other thing. Astronauts. You know, astronauts, they weigh less on the moon than on the Earth. Why is that? Well, you see, the moon is less massive than the Earth. Therefore, it has a smaller gravitational pull on the astronaut. It's like the moon is a weaker magnet. They aren't as attracted to each other. Distance also plays a role. Think back to playing with a magnet. The pull of the magnets towards each other are stronger when they are closer together. The same is true of gravity. For example, the sun is the most massive object near the Earth. It dictates most of the gravitational forces in our solar system. It is very, very massive. But it is relatively far away, so even though the sun is a much stronger magnet, so to speak, it is a long ways away. Therefore, the attraction isn't as strong. So let's look back at that law of gravity, the equation, F equals G times M1, M2 divided by R squared. You see, the force of gravity is equal to a number. That's that universal gravitational constant, G, times the mass of object 1 times the mass of object 2. Think of M1 being the mass of the sun and M2 being the mass of the Earth. And then we divide by the distance between them squared. This determines the force of attraction between the sun and the Earth. You could just as easily plug in your mass and the Earth's mass and the distance between you and the center of the Earth, and find out how much you are attracted to the Earth and the Earth attracted to you. So what's gravity? Everything is attracted to everything else. Everything. Oh, and one last thing, just to make you wonder. What causes gravity? Why are two objects with mass attracted to each other? Well, the answer is, we don't know. The cause of gravity remains a mystery to scientists. We don't really know conclusively what causes gravity. It is one of the great mysteries of science.
So, after watching that video, have a think again. What do you think we mean by gravity? So you would have heard the person in the video talking about attraction between two objects, and that everything attracts everything else. So, as you probably guessed, this video is going to be about gravity, the difference between mass and weight, and this video is also about how to calculate force. So by the end of this video, you should be able to describe the basic properties of gravity, explain the difference between mass and weight, and be able to use this equation, force equals mass times acceleration, with the correct units to calculate force, mass, or acceleration. So in the previous lesson, we learned about weight force and how it's a non-contact force caused by gravity. It's the force that stops objects from just floating up in the sky. Now, all objects with a mass produce a gravitational field that attracts everything towards it. It attracts each other with a force called weight force. And this weight force causes the object to accelerate towards each other. So what do I mean by this acceleration due to gravity? Well, acceleration due to gravity is how much an object accelerates towards another object due to gravity. Gravity is annotated or written down as a little g, and this depends on the mass of an object. So the larger the mass of the object, the larger its acceleration due to gravity. The smaller the mass of the object, so the sun is bigger than the moon, so the smaller it is, the smaller the acceleration due to gravity. As you can see, 1.62 is smaller than 274 meters per second. An important thing to note in this table here is that mass is measured in kilograms. The unit for mass is kilograms. And acceleration due to gravity is measured in meters per second. That's the unit of acceleration due to gravity. Because the pull of the sun, the gravitational pull of the sun, is larger than the gravitational pull of the earth is actually accelerating towards the sun. Because the gravitational pull of the earth is larger than the gravitational pull of the moon is accelerating towards the earth. Here's another table and a picture of all the different planets in our solar system and their acceleration due to gravity. And as you can see, the larger planets like Jupiter and Saturn have a larger acceleration due to gravity than the smaller planets like Mercury, Venus, Earth, and Mars. That's because the gravitational pull is stronger when the mass is greatest. So I've been talking about these two different things, mass and weight, and they're totally different concepts. The mass of an object is how much matter or stuff that object contains and is measured in kilograms. So Mercury has a mass of 3.18 times 10 to the power of 23 because it has that much stuff in it. Whereas Jupiter, you can see that's times 10 to the power of 27, which is a larger number than this one of Mercury's because Jupiter is much larger, it has more mass than Mercury. Whereas weight, the weight of an object is the force caused by gravity pulling down on the mass. Weight is a force caused by gravity, and it's measured in newtons because all forces are measured in newtons. So in the video that we watched in the beginning of this lesson, it talked about how astronauts weigh a lot less on the moon than they do on the Earth. But that's not talking about the amount of kilograms it has, because the astronaut would have the same number of kilograms in its mass as it would on the Earth. Because let's use bananas for example. 1 kilogram of bananas would have the same mass or amount of stuff on Earth and on the moon. If it's 1 kilogram on Earth, it's going to be 1 kilogram on the moon. But because weight force is bigger on Earth, it has a bigger acceleration due to gravity. So weight force is greatest on Earth, but mass will be the same on both moon and Earth. Alright, so we've talked about force and mass, and we've talked about weight, and we've talked about acceleration. Now we're ready to learn how to calculate forces. The amount of force applied on an object can be calculated using its mass and its acceleration. In this equation, where you have force equals mass times acceleration. The times is hidden in here. You don't have to put the times, you can just write mass times acceleration. Force is measured in newtons, mass is measured in kilograms, and acceleration is measured in meters per second per second. Now let's look at a particular type of force, weight force. We calculate weight force using the following equation. Remember, it's force equals mass times acceleration, where this time we're looking at weight force. And weight force, which we represent by a capital W, is the effect of gravity on an object. Mass, we represent that with a little m, is how much matter is in an object. And this acceleration, we use acceleration due to gravity, which is gravity anywhere on Earth. It's actually 9.8, but we sometimes round it to 10 meters per second per second. So, I would like you to get a pen and paper and do this activity in your book. In your book, you need to show your working, and I'll show you how to do that. So the activity is calculate the weight force of the same astronaut, this guy here, on Moon, Venus, Mars, and Jupiter. So we're calculating the weight force, so we're using the W, capital W. And to do that, we times the mass by the acceleration due to gravity. Okay, and that's in this equation here. So what's the mass of the astronaut? Well, it says right here, the mass of the astronaut is 50 kilograms. So we're going to write 50 kilograms next to our W equals. Then we times it by acceleration due to gravity. Let's start on the Earth. What's the acceleration due to gravity on Earth? Well, it's 10 meters per second per second. So we're going to write times 10 meters per second per second. Then you could do this in your head. 50 times 10. 500. And what's the unit for weight force? Newtons. So on Earth, this astronaut that weighs 50 kilograms, being pulled to the center of the Earth, accelerating at 10 meters per second, has a weight force of 500 newtons. I would like you to show your working like this, and do this activity for these other planets and moons. You can pause this video now. Throughout the Physical World series, we're going to build on this table. This is a table of quantities and international systems of units. As you can see, I've only filled in this part of the table, and I haven't filled in these parts because we've still got to learn about these bits here. So please pause this video, copy down the table, and write the quantities and units I've got here so far. Okay, now I would like you guys to spend the time doing these activities I've got for you. The first is Education Perfect, and it's called Gravity and Mass versus Weight. And then there's a worksheet on Lemonade, Mass versus Weight and Calculating Force. It's important you do these activities so you can practice the types of problems that you might get in a test or an exam. If you have any questions, you can ask me through emailing me or going to our help sessions. So congratulations, you've made it to the end of the video. By now you should be able to describe the basic properties of gravity, explain the difference between mass and weight, and use the force equals mass times acceleration equation with the units to calculate force, mass, or acceleration. Thanks for watching, and I'll see you in the next video.